square root of SURDS. Note, we've just dealt with equality of SURDS, which is all about equating ordinary numbers to other ordinary numbers, and also square roots to square roots. And we're going to use that technique in solving this question that says find the square root of 5 plus 2 root 6. Under this topic, you would have to say let the square root of 5 plus 2 root 6 be square root of a plus square root of b. It's just a way, since at this point they are linked by addition. When you're doing this, you also link them by addition, so you have it as square root of a plus square root of b. And then you have to equate this to this. Watch what we do. We have 5 plus 2 root 6 equals square root of a plus square root of b all squared. Since we have assumed that the square root of 5 plus 2 root 6 is square root of a and square root of b, therefore 5 plus 2 root 6 should equals, in open bracket, square root of a plus square root of b all squared. Now to explain this, it's like saying, the square root of 4 is 2, but how can 2 give you 4? You power the 2 to the power of 2. So 2 squared is 2 times 2, and 2 times 2 will give you 4. Same applies here. It's like another example is 9. The square root of 9 is 3. If the square root of 9 is 3, and this 9 cannot be equated to this 3 directly, the only way we can equate this 3 to this 9 is powering it by 2. So we have 3 squared equals 9, or 9 equals 3 squared. And same applies to this. So if we assume that the square root of this is this, for us to equate the square root to the actual value, we have to power the square root by 2. We've powered it by 2. The next thing is to break down this. That's expand. And at this point, as a further math student, you should be able to expand without doing the long process. Let's say, for example, you have a plus b all square. There's a plus b in bracket square. Expanding this, which is a plus b twice, will give you a result of a squared plus 2ab plus b squared. You can write it as a squared plus b squared plus 2ab, still the same thing. And if it were to be in this format, a minus b squared in bracket, you have it as a squared plus b squared minus 2ab. You join the a and the b with 2, but now it's negative, unlike the one with the positive where you have a positive. And the same applies to this. So let's repeat this part first. We have 5 plus 2 root 6 equals square root of a is same as a in this case, so you have it as square root of a square plus square root of b square. This represents our b. Square root of b represents our b in this case, since we are expanding just like this, and the result should be a square plus b square plus 2ab. So this is our a square, this is our b square, and then you have 2 times square root of a times square root of b. Since this root a stands for a and this root b stands for b, you have it in this form. On the next line, we have 5 plus 2 root 6 equals, we're breaking this down, we're actually expanding this. The square cancels the square root, so you'll be left with a plus the square cancels the square root, you'll be left with b. So you have a plus b plus, you have 2 times root a times root b. You have it as 2 times root a times root b. A has a square root and b has a square root, and they are linked by time, so you can give them a big square root and multiply them together, as shown in the multiplication of SURDS. So we have, on the next line, you have 5 plus 2 root 6, we're not touching this yet, equals a plus b plus 2 root ab. A times b is ab. That's just algebra. At this point, we now apply equality of SURDS, where we equate the left to that on the right. Our constant here with our roots is a plus b. It just starts simple. 5 as a constant without a root is equal to a plus b. So we have it as 5 equals a plus b. This is equation 1. For equation 2, writing it by the side, we have 2 root 6 should equal 2 root ab. So we have 2 root 6 equals 2 root ab. This 2 cancels this 2. Then you have root 6 equals root ab. You can square both sides, or you say this root cancels this root. You have 6 equals ab. That's equation 2. Now, by applying equality of SURDS, we've been able to create equation 1 and equation 2. Equation 1 is 5 equals a plus b, and equation 2 is 6 equals ab. This is a simultaneous equation, and simultaneous equations can lead to quadratic equations, so don't be afraid of that. That's actually very simple. We have our equation 1 and equation 2, and we're using substitution method. From equation 1, we make a subject of formula. So we have 5 equals a plus b. We are making a subject of the formula or subject of the relation by making a stand alone. We take this plus b over the equals to sign to make 5. It now becomes 5 minus b equals a. From equation 1, we create equation 3. Equation 3 is 5 minus b equals a, or we can still say a equals 5 minus b. If 5 has a positive, the b owns the negative. We can't substitute equation 3 back into equation 1 from where it's created. We can only substitute it in equation 2. Therefore, we substitute equation 3 into equation 2. We know equation 2 is 6 equals a, b, or a times b. We are going to replace the value of a in equation 2 with what it represents in equation 3. We're just replacing this a with 5 minus b. So we have 6 equals 5 minus b in brackets, because a represents 5 minus b, times b, that's this b. We open the brackets, we have 6 equals, this b affects both the 5 and the minus b. So b times 5 is 5b, and b times minus b, we can go with the signs first. This has a positive, we have minus b squared. We have the negative, then b times b is b squared. Now, because this has a positive, it doesn't really cause any damage, so you can just put this sign here, then multiply the two b's together. If this were negative b, it's a whole new thing entirely, and you have to be very careful with the expansion. We are creating our quadratic equation, and most times I don't like my b squared negative or carrying a negative, so we're taking minus b squared to the other side. Let's take it first. Minus b squared crosses the equals to sign, it turns to b squared. Then the plus 5b, this 5b has a plus, crosses over the equals sign and turns to minus 5b. Then this is plus 6, still on this side, you still have your plus 6 equals, you move this and this over the equals sign to where the plus 6 is. So b squared minus 5b plus 6 equals 0. We have a quadratic equation, b squared minus 5b plus 6 equals 0. And we have to factorize. The coefficient of b is plus 1, so we need not to concern ourselves with it, and therefore we need to focus just on this plus 6, which is a constant. We're looking for two numbers that will multiply themselves to give you plus 6, yet when we add them, it gives you minus 5. To get minus 5 and plus 6, that's plus 6 would have to be minus 2 times minus 3. When you multiply minus 2 times minus 3, you get plus 6. Minus times minus is positive. 2 times 3 is 6. When you add minus 2 plus minus 3, you have minus 2 minus 3. Minus 2 minus 3, when you add them together, gives you minus 5. Therefore, we can say minus 5b can be broken down into minus 2b minus 3b. So we have it as b squared minus 2b minus 3b plus 6 equals 0. We group them in twos, this and this. Note, this 3b owns this minus, so we're grouping with the negative. What's common in these two? We have b here, and we can also get b here. So we take out b. If we take out this b, from this b we take out 1b, we'll be left with 1b, because we have two b's here, that's b times b, because it's b squared. Then minus, if we take out the b, you'll be left with 2. You have 2 left here. If you want to get this back, you just multiply this b times this b, you get b squared. B times minus 2 will give you minus 2b. So we're on the right path. In this other bracket, we take out 3. You have 3 here, and you have 3 in 6. 6 is 2 times 3, so you can get 3 out of 6. We're not just taking out the 3, we're taking it out with negative. We have minus 3, we're taking it out with negative, because the reason for factorizing is so we can have b minus 2 in the other bracket. We open our brackets. Negative divided by negative is positive. 3 in 3, 1. Then you have your b. So you have plus 1b, or you can say b. So you have b here. Then minus 3 in plus 6. You have plus 6 over minus 3. Positive divided negative is negative. Then 6 divided by 3 is 2. We have b minus 2 here, b minus 2 here. We pick one of them. b minus 2 in brackets. Then you have b minus 3. b minus 3 in second bracket. Equals 0. So we say b minus 2 equals 0, or b minus 3 equals 0. b equals to minus 2 crosses over the equals to sign and turns to plus 2, or b equals 3. Minus 3 crosses the equals to sign and becomes plus 3. So you have b is 2 or 3. Since we now have values for our b, we can use these values for b to find the values for a. We can use either equation 1, equation 2, or equation 3. I prefer using equation 3, where we have a equals 5 minus b. So we have equation 3, a equals 5 minus b. That's equation 3. So with equation 3, noting that b is 2 and 3, we find the two values for our a. For the first value, when b is 2, a equals 5 minus 2. B is 2, a equals 5 minus 2, that's 3. And for where b equals 3, a equals 5 minus 3. b here is 3. A equals 5 minus 3, that's 2. From this, we know when a is 3, b is 2. And on the right, we know when a is 2, b is 3. We have now found out the values for our a and values for our b. Remember, we assumed that the square root of this equation, that 5 plus 2 root 6, is square root of a plus square root of b. That's it. So what we're now going to do is we're going to insert the value for a, which is 3 on this side, and the value for b, which is 2 on this side, for the first answer. Then for the second answer, we'll also use the value for a, which is 2, and the value of b, which is 3. Let's start with this, where we have a equals 3 and b equals 2. So we take square root of a plus square root of b. That square root of a is 3 from this, plus square root of b is 2. That's one of our answers. And on the right, still noting that on the right, where we have the value of a to be 2, you have square root of 2 using square root of a plus square root of b. Square root of 2 plus our b here is 3, square root of 3. So the answer to this question is root 3 plus root 2 and root 2 plus root 3. If you square this or square this, if you square root 3 plus root 2 or you square root 2 plus root 3, you will get 5 plus 2 root 6. You can try that. What I'm simply saying is root 3 plus root 2 all square. You square it. If you open the bracket, you get this. And root 2 plus root 3 square. If you square it, you still get 5 plus 2 root 6. That means the square root of 5 plus 2 root 6 is either root 3 plus root 2 or root 2 plus root 3. The proof. We can prove this is right. Let's do it. We have root 3 plus root 2 all square. And it says a plus b all square is a square plus b square plus 2ab. Root 3 is our a, root 2 is our b. So we have root 3 square, that's your a square, root 2 square, that's your b square, plus 2 root 3 times root 2. For this, square cancels square root, you'll be left with 3, plus square cancels square root, you'll be left with 2, plus 2 with our big root, 3 times 2. This 3 times this 2. These are constants, and this 2 is linked to this root by times. So we can't add them all, it's not allowed. We can only add these 2. 3 plus 2, that's 5, plus 2 root 3 times 2 is 6. So we see that squaring root 3 plus root 2, if you square it, you get back the original SURDS. Therefore, we can find square root of SURDS like this using equality of SURDS. I hope you understand. Summary. The summary is, if you are asked to find the square root of 5 plus 2 root 6, first you create a square root for it, which can be square root of a plus square root of b. You can make it square root of x plus square root of y, your choice. Then you create the assumed square root to the original SURDS. Then you work on the square, you expand, you get your result, then you equate. You equate the constants, that's 5 equals a plus b, to create equation 1. Then you equate the 2 root 6 to the 2 root a times b. And from there, you derive 6 equals ab, as done here. When you know your 6 equals ab, that's your equation 2. This has now formed a simultaneous equation. And with substitution method, by making A the subject of a formula or the subject of a relation in equation 1, you create equation 3, substitute it into equation 2, thereby getting a quadratic equation. You solve the quadratic equation to get the two values for B, then you substitute the numeric values for B into equation 3 to find the two values for A. Then remember, you assumed that the square root of 5 plus 2 root 6 is square root of A plus square root of B. Now you then insert the value for A and B into the root A plus root B. So you have it as root 3 plus root 2. And the second value for A and for B, you insert it into the assumed square root to get the second sort value that if you square it, you still get the same answer, which is 5 plus 2 root 6. I hope you understand. And at the bottom of it, we tried one of them, which is root 3 plus root 2. We squared it and got back 5 plus 2 root 6. This proves that we can actually find the square root of SURDS. I hope you understand. You can watch again until you grab it and memorize the steps involved.